Oh, Wednesday too. Good morning, everyone. I hope everyone's having a great day here, or good morning, afternoon, wherever, whatever time zone you're in. Welcome to the next Looq webinar here. So again, my name is Kevin Grover, where I lead the customer success team for Looq. And this week's webinar is going to be about working on Looq data within Trimble Business Center. I'm joined by Lucas, who is our VP of product, and he's going to help out with some of the demo here today as well. So we're going to kind of kick things off on my end and the kind of regular housekeeping stuff kind of along the way, and a little intro to Looq and talk about some of the data. And then I'm going to hand it over to Lucas to do a bit of a live demo in TBC. Perfect. So for those of you on the call that aren't familiar with Looq, we are a handheld photogrammetric mobile capture platform that is entirely imagery based. Our QCam is our capture device itself. It is a multi-camera system. It has the built-in IMU and survey-grade GNSS, and we have a complete web processing package that does all the point cloud processing, orthoimagery processing, generates classified point cloud data, and all in a simple, easy-to-use web application that we call QApp. QApp is our web app, and it allows you to view, navigate, export, share, and work with the data in our friendly, easy-to-use web application. So, as far as the capture within a Looq device itself, like I said, it is handheld based. We do leverage PPK GNSS corrections, so it allows you to set up a local base station for doing survey capture. We have an auto processing solution that allows you to pull data from CORS networks. You can use SmartNet corrections or any of the Trimble processing corrections as well, and allows you to walk your sites in a mobile application using the handheld device. We can do up to 30-minute captures within our device itself. It allows you to just wander around project sites, collect data exterior for roadways, intersections, and that's the project we're going to focus on here. Overhead utilities we can basically do with it as well too, so you can walk and navigate around power poles, power lines, collect all this data, and we can generate these rich 3D environments. As far as the office processing, this does allow you to create projects within our web application. We do have tools to fit to ground control to basically generate 3D data sets that are going to be survey quality. So we can generate basically RTK quality data. And then also we've got some tools for our Q survey, which allows you to extract some information, which I'll also show you here today as well. And all of this data can be exported into products like TBC. So we're kind of going to be talking about a little bit the soup to nuts kind of end-to-end workflow for doing the collection and bringing this into a Trimble Business Center environment. So next thing I'm going to dive into just one of our sample projects for just a survey project of what we do. I've got some screenshots, but also share with you in the web application. And this is what Lucas is going to bring into TBC. So for a simple kind of linear corridor project, this is kind of the capture path. We want to do these walking paths back and forth that allows you to collect these data sets at walking speed. So this was about a short stretch of road. It ends up being about a probably 12 to 15-minute capture with control points we put in. You can do up to 25 to 30-minute captures within a single collection. You're walking the parallel lines as you walk back and forth along roadways. We do kind of close off loops at the intersections and basically get this survey quality data set. You need a minimum 3 GCPs to georeference, and that will kind of, I'll show you the align to control workflow, just kind of what we do for it and how we can get this survey grade data. As far as the results we get out of it, we do get a point cloud that is a colorized point cloud because we are imagery based, but we do also have AI extraction. This allows us to basically classify the data into some intelligence. These classifications do follow the export, so we do export an LAZ file. All of these classifications do get exported as part of the LAZ, and that's what we'll also be bringing into TBC to generate a ground surface. And you can also fully classify data again within Trimble Business Center as well. So I'm going to dive. I do have some screenshots here, but I will show you the web application in a moment too. But as far as the align to control, this is really the benefits of our product is we do allow you to do the PPK process and to get you close with the data set right off the bat. The align to control point does allow you to actually use ground targets and adjust the data to control. So you see on the right-hand side of the screen, as you can see the residuals we basically get out of the capture. And we put down a few RTK quality targets and we're able to align our data to that. And we're getting residuals that basically meet that. So all of the residuals in this case are under a centimeter, and that just happens to be because it's been a great capture, and then using RTK quality controls. This is what we can expect to kind of get into our application. I am going to bounce over, I'm going to stop sharing this, and I am going to start sharing my web app, and I'll just show you this bit of the data live and how to export data out of our product. Just stop presenting this, and I'm going to share a window here. Perfect. Hopefully that pops up. This is the same data set we're basically seeing in the 2D environment. So we can see the 2D map. These are all the images that were captured. We could turn on the ortho, which is one of the products that we get export out here as well too. And this is where, for doing things like utility markouts or basic kind of two-dimension extraction, we can basically see the data that gets exported. So the quality we're exporting is enough to read markings and things on the ground, and we'll be able to export this out as a geotiff. So our 2D map shows us this data. The 3D view is exactly what it's showing in the screenshots, but it's nice to see the data in 3D here. And we're able to see the 3D point cloud. And it's just going to load more of the data as I'll stop navigating around here. But this is the data we're able to load. This is where we can start extracting this data using our Q-Survey tool as well. So with this, we can extract curb and gutter, that kind of thing as well. The classification, as was asked, is we do classify our data. These are exportable as well, but you can start seeing the data that's classified within the environment. So I can turn my road surface data on and off. Again, it's not perfect. TBC's got classification as well that you can also reclassify, which Lucas is going to show here too. So the first thing that I want to do is all of these data can be exported. So in our Files tab, this data that we have here, we export the point cloud as an LAZ file, the ortho as a geotiff. These are the two big ones that you're basically going to be exported out of here, and we've already got that done, and we'll bring into TBC. The last thing that I'll show you before we bounce over to the TBC work is the extraction functionality that we do have within our environment. So we can come into our virtual survey tool. I've already extracted some of this, but I will walk through just a very basic extraction. And this is where you can do some simple line work and point extraction within our viewer. So in this case, maybe I want to do a bit of curb. I can bring up a virtual survey. I'm going to come in call it just for webinar. And I can run a code profile. So in this case, I can run even like the TBC library, or I've got a Looq default one. I'll pick, say, the TBC one. This is just their default library that we have set up within here. So all of these things end up being points or line work that can be extracted. So things like, these sorts out of order. I've got like gutter left. I can basically do left and right gutter, paint lines, all of these things. I can do maybe some paint line extraction, just very basic. So I'm going to start my virtual survey, and this allows me to start extracting data within environments. If I want to do some paint line extraction, I can see that in my data here. It builds the layer list on the side. I can enter my point numbers, and I'm going to enter in a code for paint line. It's going to detect that as a code. And then I can basically start picking data within my 3D environment. This is now going to generate 3D line work just from clicking within the data set. So if I navigate around in here, I can actually see that I've extracted line work. It does have beginning and end of curve, beginning and end codes for control codes. These are also going to be read into TBC or to Civil 3D as well. So I have already extracted a data set that we're going to bring into TBC. So if I open up this one that I've done already, you can see this took probably a matter of 15 minutes to basically go through and extract out edge of sidewalk, curb lines, paint lines, some spot elevation markings, and all of these things are exported out just as a CSV file. So now we've got a point cloud that's classified, the ortho photo that's as a geotiff, and then this extracted line work that we can now bring into TBC. So I'm going to turn the sharing over to Lucas here, and he's going to walk through showing you how to bring some of that in.
Thanks, Kevin. Okay. You see my screen there, Kevin?
Sure can.
Great. Okay. So as Kevin mentioned, you can export a couple things out of our platform. I've done a little pre-work here because it takes a couple minutes to load it in. I want to make you guys sit and wait and watch it render. So the important thing to note, I think, before you start bringing the data set in is to set the coordinate system. If you drag and drop are the ortho and the point cloud in first before setting it, it can occasionally result in scaling errors. So go into your project settings, you can see here, I have set the coordinate system for this job, UTM 12 north, and I did that. The next step is you simply take the geotiff and the LAZ file and you just drag and drop them right here into TBC. It'll take a couple minutes to load, but you can see that they're both in here. And then something that I always do, which I think is just a good rule of thumb, is to bring in your ground control. So even if you've run the align to control module and you're confident that everything's lining up in the Looq platform, it's always a good, just check to drag everything in and then import your ground control, which you can just do here on the import points list. So now that I have everything all set up and I'm confident that it's lining up with my ground control here, the next step is to bring in the points from our virtual survey. So start, I'm going to turn off the point cloud here in my view manager, and you bring those in the same way that you would ground control points. I'm just going to hit import, and I'm going to select this. Make sure you select the same coordinate system that you have for the project. And now I'm going to hit import. Easting, northing elevation, we export XYZ out of our platform. And then I'll hit import. Bringing in the ground control points I already have in here. So that part of it. There you go. So now initially you can see your points are coming in. You want to make sure that everything's lining up in between what you've done in the field and then here. The next thing that you need to do is process the line work. So I have set it up so that I just use the default field codes in Trimble Business Center. I know that you guys all have your own field codes probably, but the most important thing to make sure is that the field codes match and the labels match between what TBC is expecting and what you've done in the Looq platform. So we actually took the feature code manager and imported all those codes into our platform as a TBC one, which if you want the standard one, reach out to us. We already have that. If you have your own custom one, you'll have to make sure that's set up correctly. But I've already done that. So now I can go ahead here to survey, process the feature codes. So to start, I'm just going to bring in the feature definition file. As I mentioned, I'm just using the default global features one. Of course, you can use whatever one you want. And then I'm going to select this file that I just imported, and I'm going to hit process on it. And there you go. You can see that everything is strung up appropriately in the same way that it was in the Looq platform. And I have it overlaid onto the imagery, so I'm confident it's good to go. So from here, there's a couple different options. You can actually build a surface off of the point cloud itself, or you can just build it off of these points and lines here. So I'm going to take a very simple approach to start. I'm just going to select the points that I want. Since we already have our spot elevations here on the road, I don't really need any other supplemental points from the point cloud itself. And then I can go in and I can create a surface file off of this. So got 377 things selected. Nice green surface, so that's easy to see. Hit OK. Now you can see it's created a tin surface here. It's triangulating in between all of my line work. Since that was done nicely in 3D, we can use all these points. You can grab them all and do it. You can also split it up by layer. If you have certain layers that are 2D and other ones that are 3D, you can kind of manage that. Trimble's got some options for that. And then if I load it up here in 3D, you can see I've got a nice thin surface here, all ready to go. Similarly, you can have 2D planimetric displays. We got a signpost in here. You can bring another 2D information for mapping purposes. But that's very simple, very straightforward. It creates a very even thin surface. I think similar to what you'd expect from the general topo survey. Now, if I was to take the different approach and to generate it off the point cloud, I'll go back here to my plan view, filter manager. So turn off the surface that I've just created and select those, and I'm going to turn on the point cloud itself. So you can generate, let's say, either a preliminary surface, or if you're doing earthwork and you don't require any break lines, you can actually take our full point cloud and generate the surface off of that. Doesn't create quite as nice clean triangles as this method, but often it's, you know, good enough for the work that's being done. And the best way to do that is actually go back here to the Project Explorer and to look at the point cloud regions. So Kevin showcased the classifications a little bit, and you can go into our platform and see what all the class names are, if they are just kind of ASPRS standard, you know, plus some additional ones that we do ourselves. But you can see I got ground here, I got road surface, and then we have additional ones and walkways to kind of fill out the ground. And what you can do here is you can actually add them to a new region. So if I go over here to point clouds, I could create a new region based on these. And then after that, I could classify that region. For example, say I wanted to refine the ground class using Trimble's refine classification step. This is nice. It gets rid of any, you know, floaters or noise points. It's just like another way to kind of filter down and make sure you're getting ground only. And then once you're done doing that, you can just do the same method, right? You select this refined ground class and you create a surface off of it. It takes about 5 or so minutes to build. So I've done that here on my other instance. So I'll bring that one back to show you what that guy's looks like instead of making you wait and watch it all build. And there you have it. So I built it out. If I go back to my plan view, you can see I've created this refined ground class, you know, from just the Trimble data, and then built the surface off of it. You can see there's a lot more points in there. It's not quite as clean as the actual triangulated, you know, virtual survey method, but often you can use this as a way to get started with some preliminary contours, especially if it's just an earthworks project. Or you can even bring in your break lines that you've done from virtual survey and kind of add them to this TIM to help refine it. So some different options there. Once again, it's a nice workflow or set up to our coordinate system-based environment and point clouds and ortho to go right into TBC and kind of keep you going with the workflows that you guys are used to doing. So I think that's pretty much it from my end. Maybe I'll open it up, turn things back over to Kevin if there's any questions in the chat or the Q&A that have come through. Happy to answer those.
Yeah, for sure. There was a couple, I guess. Yeah, regarding classification from Lewis, I know we already kind of answered that one about classification. I don't know if there's any other follow-up questions on it, but it does allow you to work with our classifications or reclassify the data yourself. Trimble's got some great tools for it in both their free product as well as in their point cloud add-on functionality. There was a question about usage fees. Yeah, I did respond on that as well. We are a subscription-based product for both our hardware and software. So we've got a couple of entry-level packages, pro packages and enterprise as well. You basically get the QCam, which allows you to use a small handheld device for doing the field capture. And then we do offer the full cloud processing for all the data processing that you've seen to generate these data sets. And then that does also come with the ability to do all the ground control workflow, the Q survey functionality for the virtual survey tools, and be able to export and share all of this data out in our simple web application. The benefit of it is we don't have user limits on our platform as well. We only have processing limits. So based on the different subscription options, we've got a different level of basically area-based processing for the size of your project, but they're all very reasonable in our mind for the price for the collection and the processing. You get some very, very good data out of it that you're basically seeing here, that you're getting some survey quality data. But please reach out for it, and we'll be following up with people if you do have more questions on it. Around temperature limits, we do have temperature limits on the device. So we can work in freezing conditions with the device, but typically when we're in freezing conditions, of course, you're limited to snow on the ground. That's where, of course, I think we're more limited on the types of conditions. So we don't work in, again, rainy weather. You can do collection in snow covered. Of course, we're photogrammetric captured, so really like any other scanner, you're going to get what you see. So if there's snow on the ground, all of our reconstruction will basically generate the snow. It'll look white in a lot of spots because, of course, photogrammetry doesn't work well with a lot of snow cover, but it actually does work surprisingly well in areas where there is some snow cover on the ground. So I'd say our bigger limitation is more just the environment that you're actually capturing rather than temperature limitations. We have some folks working in like Las Vegas in the summer and able to collect in like high heat temperatures, but you are going to be limited just as you are with any other technology. But I think it is more around that thing. I'm not Lewis if that answers your question or not, but perfect. That's great. I see Stefan is typing as well. I guess it's a small group here. We could unmute people if that works as well. I think Teresa might be tied up to unmute, but I could maybe give it a try to unmute people. I know how to do that. I guess if anybody's got a question, for sure, we can make a copy of the presentation afterwards, or Stefan, we're happy to reach out and do something for your team directly if you're interested. So maybe we can do that as a follow-up if you're interested in doing something directly for your firm. We could look at doing that afterwards. So. Perfect. Maybe if anybody else does have any follow-up questions, please keep them coming. I am just going to bounce back to our presentation here, and we will close things out with just where our next webinar series is and how to get in touch with us. I will have to start the screen sharing at the end here again. So yeah, a couple closing announcements. We do have our next webinar that's going to be popping up. It's March 17th. We're going to be diving into a bit more of the ways of the different options of exporting and sharing and some of the data we get out of the products. We're going to be doing that in our next one on March 17th. And then we're going to be going to a monthly webinar series after that. We do also have our user conference coming up in May, which is going to be hosted in sunny San Diego. So we do have some early bird pricing that's still available for, actually, sorry, early bird's over now. I have to update the slide on it, but please, if you're interested in reaching out, we're going to have a lot of hands-on demos and some other things we're doing with our user conference. So perfect. There's another question from Lewis here. Not sure, but the tool used LiDAR and photogrammetric processing. So no, we are actually only photogrammetric based. So we do not have a LiDAR sensor on our current device. It is a handheld photogrammetric sensor only. So I can actually show that here. Maybe I'll stop sharing my presentation here so you can see my screen in full. The device is actually a small handheld capture device. We actually have 4 cameras with the GNSS device built right into it. So we are similar to some of the SLAM systems of the market, but what we also do is we are purely photogrammetric based and able to reconstruct areas in 3D. We use the absolute and relative accuracy is all from the PPK processing as well as from our ground control point workflow. Okay, so there's some issues with cables. Lewis, do you want to clarify what you're talking about that? We do have an external, we do have one cable on it. The cable is basically just the external battery pack, but it does allow you to extend the cable. You carry basically the battery pack on your hip or within your survey vest. And it really is just to kind of keep the device lighter weight. We are 3 pounds for the device, so it's meant to be a really small handheld system that we're just not cluttering it with the battery directly on the device. I see typing. Oh, capture wires. Yeah, no, we can actually collect wires entirely from the photogrammetric system. So I will, maybe just to show you that, I will actually just bounce to a data set here since we do have some time. I will load up one of the power data sets that we did. This was just about a 10-hour captured on the roadway that I collected. This is the level of detail that we're basically able to get just from a walking capture with overhead power. So of course you'll get, you get a bit of noise on data, as you will really with any technology, but for the most part, it's more than adequate for doing any kind of power line modeling with your data. So you see, even we get all the mid-span data along the data set, but then actually at the poles themselves, we're able to get the data around the ground. We are limited to what you can see. So if there's vegetation and objects obscuring any of the data in any way, we're able to generate, what we can visually see, but basically all of the attachment points, conductor locations, basically whatever else you want to do for pole assets is all captured from ground level with a handheld device. So that's actually one of our bigger markets. A little bit different from what we do from TBC for this webinar, but we've done some past webinars on doing like overhead power infrastructure. But that's actually one of our biggest use cases. The benefit out of this too is we also fully classify this data really, really well. So actually our wires are classified, as you can see here. This is done all automatically as part of our fees for our service. You do the collection, we do all the 3D processing to generate the point cloud, and it's fully classified as you see there for all of the wires, poles. We've got a new feature that's coming up for QPole that's going to allow us to do other kind of pole extraction. So we're working on really a lot of other features just to make this easy for collection, but easy to process and easy to extract. So hopefully that answers your question there, Lewis. But yeah, love to follow up if you got more questions on that too. Perfect. Guess we got a small group. If there's anything else, yeah, happy to answer any other questions. We got a couple minutes left here, and if not, we'll reach out afterwards and we can get something scheduled one-on-one if you're interested. Seeing nobody typing, I guess we'll call it. So perfect. Thanks everyone for this, and this will be posted up on our webinar page so you can watch the recording afterwards, but feel free to watch our next one coming up in 2 weeks. Thanks everyone. We'll talk. Take care. Bye-bye.
Everyone.